Okay, imagine this. What if you could actually see the shape of a melody, or taste the color yellow? I know it sounds wild, but for some people, this kind of blending of the senses is a daily reality. But what's really blowing my mind is that we're now engineering AI that can do something very similar, creating a seamless, almost magical connection between what we see and what we hear. So let's dive into how we got here.
So this whole phenomenon has a name. It's called synesthesia. It's a real neurological condition where, for instance, hearing a certain musical note might make you automatically, consistently see the color blue. And no, that's not a metaphor. It's a genuine automatic experience. And this very idea, this merging of the senses, is really the key to understanding the next huge leap in AI.
You know, for centuries, art has pretty much targeted one sense at a time, right? A painting is visual, a song is auditory. The experience, a lot of the time, can feel kind of passive. But AI art, it's completely flipping that script. It's moving us from that single sense thing to a full sense, totally immersive experience where sight, sound, and even our own perception all get tangled up together. It's a huge shift from just looking at something to being in it.
All right, so here's the game plan. We're going to start with this long-standing artistic dream of merging our senses. Then we'll get into why the first AI videos felt so off, so disconnected. After that, we'll look at the massive technical breakthrough that fixed it, check out the incredible creative tools this whole thing unlocks, and finally, wrap up by asking what this all means for the future of how we perceive things.
Okay, first up, art's sixth sense. Now, this idea of connecting what we see with what we hear and feel, that's not some new AI thing. Artists have been chasing this dragon for ages, trying to create one unified, powerful experience. But what's the actual glue that holds all these senses together in our brains?
Well, that glue is something called kinesthesia, our sense of motion. It's often called our sixth sense, and it's basically the bridge. It's what integrates everything. It's the deep fundamental sense that lets our brains naturally connect, say, a high-pitched sound with something rising, or a deep, heavy bass with a powerful, heavy impact. It's the secret sauce that makes these sensory connections just feel right.
So if our brains are already wired to do this, how does that translate to AI? If we're built to connect sound and motion, why did those early AI videos feel so weird and out of sync? It was kind of like watching a badly dubbed old movie. This became the central challenge that AI engineers absolutely had to solve.
And the problem was this really flawed process called cascade generation. Basically, the AI would create all the visuals first, like an animation of glass shattering. And only after all that was done, a completely separate process would try to slap the sound effect on top. The audio was treated like an afterthought, this poor orphan that just got bolted on at the very end.
And the result? Just this jarring, awful desynchronization. The sound of the glass shattering might come a split second too late or too early. A character's lips would be totally out of sync with their words. This created what creators started calling the gotcha problem, like a slot machine. You'd have to generate maybe 5 videos just to get one that was usable. We're talking a success rate of only about 20%. It was totally unreliable, super frustrating, and made any kind of professional work pretty much impossible.
So the big question is, how on earth did they fix it? And this brings us to the synchronized breakthrough, led by models like ByteDance's Seedance 2.0 and Kuaishou's Kling 3.0. The solution was a totally new way of thinking, and it's all rooted in something called a dual-branch architecture.
And there's a fantastic analogy for this. Think of the old way, the cascade method, as having an artist and a sound engineer working in separate rooms. They never talk to each other. They just pass their work under the door. The new way, this dual-branch system, is like a single musician who sings and plays the piano at the exact same time. The hands and the voice are perfectly in sync because they're coming from the same mind.
So how does this work under the hood? It's seriously clever. They take the audio and they convert it into a visual picture called a spectrogram. By turning the sound into a format that looks like video, both parts of the AI, the audio branch and the video branch, can finally speak the same language. The AI can literally see the sound and generate visuals that perfectly match its rhythm, its pitch, its intensity, all in real time.
And the result of all this? It's a revolutionary leap in reliability. The gotcha problem, gone. Instead of that miserable 20% success rate, models like Seedance 2.0 now have a usable output rate of over 90% on the very first try. I mean, this changes everything. It takes AI video from being this unpredictable science experiment and turns it into a reliable, industrial-strength production tool.
But this breakthrough isn't just about making things more reliable. No, it unlocks a whole new universe of creative control. It's like suddenly every single user has the power of a film director sitting right there in their pocket.
The flexibility you get is just insane. Take a look at a model like Seedance 2.0. While other models might take a text prompt and maybe an image, Seedance can handle up to 9 images, 3 different videos, and 3 audio files all at the same time. You can literally tell it, okay, use this picture for the character, this video for the camera movement, and this audio track for the rhythm. You're not just generating a video anymore, you're composing one from all your creative pieces.
And the tools you get are just incredible. It really is like having a virtual film crew. Kling 3.0 has a motion brush that lets you literally paint where you want movement to happen on an image. Seedance 2.0 actually understands cinematic language, so you can tell it to create a lateral tracking shot and it knows exactly what to do. You get perfectly lip-sync dialogue in multiple languages, and you can even upload an ad you really like and just say, replicate this style. It's wild.
So, let's bring this all the way back around. We started with the human brain's amazing, innate ability to merge our senses together, and now we've gone and built machines that can do the very same thing, but with a level of precision and control that is just staggering.
Which leaves us with this one last really fascinating question. When an AI can perfectly sync a visual explosion to a sound that it generates, or create a dance that perfectly matches the rhythm of a song it's hearing for the first time, are we really engineering a new form of digital synesthesia? Or have we just become masters at creating an incredibly powerful, incredibly convincing simulation of it? What do you think?